Hi, Math to Enhance. Let's look at these notes for completing the square on page 5 of our packet. So when you're going to use the method of completing the square, you want to make sure that your A term is equal to 1. So if your A term's not 1, you need to work on it with some algebra first. So let's look at number 4. So we've done completing the square before. We had a step 1, we have our setup. That's when we put our x squared plus our 16x together, leave a space. And we move the 36 to the other side, so I'm going to add 36 over. So step 2 is when you and I do our complete the square work. And that's when, to find my C, the C that would complete the square, I do my B divided by 2 and I square it. So in this case, my B is 16, so I'm going to do 16 divided by 2, and I'm going to square it. I get 8 squared, I get 64. So this is when I'm going to add 64 to both sides, and I also balance the equation. That's where I add it to both sides. So first of all, I put my 64 with my x squared plus 16, because that makes a perfect square trinomial. I'm going to be able to factor that into a binomial squared, which is the whole point of this process. The whole point of this process is for me to be able to factor this, or not factor exactly, but to solve this equation. So I need a method to do that. But if I add 64 to the left, I need to add 64 to the right. And so now my last step is to factor and solve. So my x squared plus 16x plus 64 factors into x plus 8 squared. So we learned last semester 2 different ways to get that. First of all, 8 was the number in the middle of my step 2, completing the square. So I know 8, positive 8 goes in my parentheses. Or it's the square root of the first, square root of the third, sign from the middle. Again, this is coming from our Unit 6 work with circles last semester. And 36 plus 64 is 100. So now that I have this, now I'm able to solve both sides by taking the square root. So I can take the square root of the left and the square root of the right. And when I do that, on the left side, I get x plus 8, because the square root and the square cancel, equals plus or minus 10. So now I need to solve for x by moving my 8 over. I'm going to subtract it over, and I get x equals negative 8 plus or minus 10. Now that is 2 different answers. That is negative 8 plus 10, which is x equals 2, and negative 8 minus 10, which is x equals negative 18. So whenever you get whole number answers for your x, your original problem would have been factorable. If I could pick the way I solve it, of course factoring goes much more quickly. But if you're not allowed to pick the way and you're told, hey, you have to use completing the square, this is how you would do it. And the fact I got whole number answers, integer answers, tells me that it would have been factorable if I would have had the option to pick that method. So the next problem is factorable as well. So if I got to pick the way to solve it, I would factor it. But if I have to solve it with complete the square, let's do our setup. That's my x squared minus 10x, leave a space, equals 11. And now we're going to do step 2, completing the square. I'm going to take my negative 10, divide by 2, and square it. I get negative 5, which is going to go in my parentheses when I factor, squared, which is 25. So this is where I add 25 to both sides. So I create my perfect square trinomial on the left, and it looks like I'm getting 36 on the right. So I'm going to factor that, step 4, and I get x minus 5 squared equals 36. I take the square root of both sides, and x minus 5 equals plus or minus 6. I'm going to move that 5 over by adding it. I get x equals 5 plus or minus 6. So x equals 5 plus 6, which is 11, or 5 minus 6, which is negative 1. So let's take a look at C. So C is an example of a problem that would not be factorable. That's not an option. So my only 2 options to solve C would be completing the square or quadratic formula. So let's look at this one with completing the square. step 1, my x squared and my 6x together and leave a space, move my 2 to the other side. And now I'm going to take the 6 and divide by 2 and square it. I get 3 squared, I get 9. 9 is the number that I'm going to add to both sides, plus 9, plus 9. So it looks like I'm getting, when I factor, I'm getting x plus 3 squared equals 11. I take the square root of both sides. I get x plus 3 equals plus or minus the square root of 11. I need to subtract my 3 over to get the x by itself. Now that is a great answer. I do want to point out it's 2 answers. So this is negative 3 plus the square root of 11. And it's also negative 3 minus the square root of 11. Now these are these are exact answers. So I could write it any of those ways. I could use the plus minus, or I could write a plus for one and a minus for the other. I can also do that on my calculator. And if you do negative 3 plus square root of 11, I believe you get 0.32. And if you do negative 3 minus the square root of 11, I believe you get negative 6.32. So you are also welcome to answer, see if I can, sorry, it's hard to write with my Apple Pencil sometimes. You can also write those 2 answers as decimals if you want to calculate them. So let's take a look at D. Again, let's do my setup. X squared minus 2x, leave a space, equals 1. Negative 2 divided by 2 squared is negative 1 squared is 1. That's the number I'm going to add to both sides, plus 1, and then I get x minus 1 squared when I factor equals 2. I now take the square root of both sides, and I get x minus 1 equals plus or minus the square root of 2. I'm going to add my 1 over to get it away from the x, and so I get x equals 1 plus or minus the square root of 2. So that is 2 answers, and that is an exact answer. It's great to answer this way. You could write it as x equals 1 plus the square root of 2 and x equals 1 minus the square root of 2. So you could write it as 2 separate answers. And you can also put that in your calculator. I don't have it right in front of me right now, but you could do 1 plus the square root of 2 and get the decimal, whatever that decimal is. And you could do 1 minus the square root of 2 and get the other decimal. So let's take a look at E. On E, my problem is that, first of all, when I do my setup, I get 2x squared plus 14x, leave a space, equals negative 3. So now, the real issue I have on this one, and I'm trying to get my highlighter here, is that my A is not 1. Your A has to be 1 for your completing the square steps to work. So whenever your A is not 1, and you have to use the completing the square method, you are going to, oh, I'm sorry, I thought it was on a pin. You're going to go through and divide everything by that leading coefficient so that your leading term has a coefficient of 1. So now I've got x squared plus 7x, leave a space, equals negative 3 halves. Should I write that as negative 1.5? You totally could. I'm going to leave that there for a moment. So now I'm going to do 7 divided by 2, and I'm going to square it. I get 3.5 squared, and when I square 3.5, I get 12.25. So that's the number I'm going to now add to both sides. So plus 12.25 and plus 12.25. So now let's talk about the left side when I'm supposed to factor it. I can get my number that I need from 2 places. First of all, this is the number that's going to go in my parentheses. It's the number in the middle when I complete the square. I also know I can do square root of the first, square root of the third, and sign from the middle. And the square root of 12.25 gets me back to 3.5. And I have my x and I have my plus. So that's me factoring it. Sorry, I should switch back to blue. Equals. Now this is where I have to do negative 1.5 plus 12.25. And when I do them on my calculator, I get 10.75. So now I'm going to take the square root of both sides. When I take the square root, I get my x plus 3.5 over here equals plus or minus the square root of 10.75. I'm now going to subtract my 3.5 over, and I get x equals negative 3.5 plus or minus the square root of 10.75. And that answer is really an okay answer. It's great. There's nothing wrong with it. But maybe you need to know where the x-intercepts are as a decimal. Like, you need to go find it. It's kind of hard to show on the iPad. It will be easier if you were in the classroom. But you're going to take your negative 3.5 and you're going to add the square root of 10.75 to it. And I believe you get negative 0.22. And then you're going to take your negative 3.5 and you're going to subtract the square root of 10.75, and you're going to get negative 3.5, I believe, if you have trouble with that. Now, this is an exact answer, and it's fine, and this is approximate answers, and I like both. So, F, when I line up my 2x squared plus my 8x and leave a space equals 10, I notice that I have a leading 2. So I'm going to divide every single thing by 2 again. This time, I don't get a decimal over there. So I get x squared plus 4x equals 5. And I'm going to take my b, divide by 2 and square it. I get 2 squared, I get 4. So now I'm going to add 4 to both sides. And I get x plus 2 squared equals 9. I square root both sides. I get x plus 2 equals plus or minus 3. I'm going to subtract 2 over. I get x equals negative 2 plus or minus 3. I'm going to do my math since they're all integers. Negative 2 plus 3 is 1. Negative 2 minus 3 is negative 5. The integer answers tell me that my original problem was factorable. Probably if you and I had factored that, we'd already be done by now. So the next part of these notes was the quadratic formula. So let's take a look at that. So for the quadratic formula, actually, I'm going to move this back down, see if I have a little bit of space. I don't really see where I can write the quadratic formula really nicely on my paper here, so I'll just write it out to the side. My x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. So in this problem, we identify what our different coefficients are. So in this problem, a equals 1, b equals 7, and c equals 12. This is another one you need to have set equal to 0 so that you get the right a, b, and c before you get started. So let's put our numbers in. X equals negative 7 plus or minus the square root of 7 squared, which is 49, minus 4 times 1 times 12, all over 2 times 1. So on my next line, I get x equals negative 7 plus or minus the square root of 49 minus 48, all over 2, equals negative 7. Actually, I'm going to go down a line because there's not much space for the other problem. X equals negative 7 plus or minus the square root of 1, which is 1 over 2. So now that I have all integers, I'm going to do my math. So on top, I get negative 7 plus 1, which is negative 6. Negative 6 divided by 2 gives me a negative 3. Or I do negative 7 minus 1, which is negative 8. And negative 8 divided by 2 is a negative 4. Again, since I got integer answers, I know that that would have been factorable, the original equation. So let's take a look at the next problem. I have to subtract my 15 back over. I get x squared plus 9x minus 15 equals 0. And my a is 6, my b is 9, my c is negative 15. And let's get started. My x equals negative 9 plus or minus 81 minus 4 times 6 times negative 15, all over 2 times 6. So my next line, I get x equals negative 9 plus or minus. Now, inside my radical is a place where students make a mistake. So let's look at let me grab a highlighter. This guy right here, this is technically a -4 times a 6 times a negative 15. That is a positive number. That is a positive 362, I believe. So be careful that you realize it's a positive number in the end, all over 12. So x equals -9 plus or minus 441 all over 12. The square root of 441 is 21. So it's -9 plus or minus 21 over 12. So -9 minus 21 is -30. -30 over 12 reduces to -5/2. I don't know where to write this. X equals -5/2. And -9 plus 21, I believe, is negative, it would be positive 12. And 12 divided by 12 would be what, 1? So those are my answers. I kind of wrote in the space for my next problem. So we'll give this a try. I'm going to write in red because my area has gotten very crowded here. I apologize. So my A is 1, my B is -8, so x equals a -8, so those are going to cancel. Plus or minus, -8 squared is positive 64, minus 4 times 1 times 11, all over 2 times 1. So x equals 8, plus or minus the square root of 64 minus 44, all over 2. So x equals 8 plus or minus square root of 20 all over 2. So let's talk about a couple different ways you can look at this. So the square root of 20 is 4 times 5. So I know that I could write this as x equals 8 plus or minus the square root of 4 is 2. So it's 2 square root of 5 all over 2. So when you go to cancel things, you need to think about this as x equals 8 over its own 2 plus or minus 2 rad 5 over its own 2. So when I go to cancel, I would get 4 plus or minus the square root of 5. Be careful you don't just cancel, like for instance, the 8 and the 2 and get 4 plus or minus 2 rad 5. You need to make sure that you're careful about that. Now, if you're a student that's saying, wait, you lost me when you went from the square root of 20 to 2 square root of 5, please come to office hours and talk to me about that if, for example, you weren't doing that last year in your class. Now, secondly, if you want to avoid that completely, back at this part right here, you could have just went to decimals. On top, you could have done 8 plus the square root of 20, hit equals. Make sure you hit equals and then divide by 2. I believe you get 6.24. And then you could do 8 minus the square root of 20. And then you'll divide by 2. I believe you get 1.76. Those answers are also great with me. Just kind of depends on which way you find it that you like to leave your answer. Sorry about how messy that last problem was with everything written there. Let's take a look at D. So D says a model rocket is launched from the top of a hill 10 meters above the ground. The rocket's initial speed is 10 meters per second. The height can be modeled with this equation. T is the time in seconds. How long does it take it to reach the ground? Well, the ground is at a level of height of 0. So I'm going to substitute my 0 in. I have -4.9 t squared plus 10t plus 10. So my A is -4.9, my B is 10, and my C is 10. So I get my T equals -B, so -10 plus or minus the square root of 100. Minus 4 times -4.9 times 10, all over 2 times my A. And so I'm getting my time equals -10 plus or minus the square root of 100. And be careful here because this is another example of when you really have a negative times a positive underneath there. So you should be getting a positive 196 all over negative 9.8. So I have t equals negative 10 plus or minus the square root of 296 over negative 9.8. So then I'm not even going to bother trying to simplify any of that because in a problem where I want time, we usually end up in decimals. So this is two answers. My t equals negative 10 plus the square root of 296 over negative 9.8. And my t equals negative 10 minus the square root of 296 over negative 9.8. So when you put those in your calculator, don't forget when you do the numerator to make sure you hit equals if you're on the classroom calculator. If you're on the navy blue calculator, you could put the numerator in parentheses if you wanted to. But we should do negative 10 plus the square root of 296 and hit equals, and then divide by negative 9.8, and we should get negative 0.735 seconds. And then we'll do negative 10 minus 296, the square root, over, hit equals, divided by negative 9.8, and you should get positive 2.78 seconds. And since we're talking about the time for a rocket to land on the ground, we don't really want the negative answer, we just want the positive answer. I'm going to make a separate video where I do a couple of the homework problems from completing the squares worksheet and also from the quadratic formulas worksheet. So if you would like some additional help when you're doing the homework problems, look for those two videos. Thank you.